What if I told you the ground under your shoes might not be the bottom of the world, or that the very air you breathe is protected by a force field generated deep within the planet? Stick around, because in the next few minutes we're cracking open 7 Earth theories that range from Nobel Prize solid to, hold my beer crazy. By the end, you won't just look at our planet differently, you'll wonder how you ever saw it as anything less than an astonishing living enigma. Seriously, prepare to have your mind a little bit blown. Quick confession. I used to think Earth was just a rocky ball with some water on top, spinning predictably through space. Pretty standard, right? Then I tripped over a rabbit hole of ideas, some backed by rigorous scientific data, some fueled by pure, unadulterated imagination, and suddenly our planet felt less like a simple sphere and more like a cosmic onion. It's got layers, deep mysteries, and, yeah, a few tears if you peel through the conventional wisdom too fast. Today, we're not just scratching the surface. We're counting down 7 of the wildest, most thought-provoking ways to rethink the place we call home. And trust me, number 1 flips the universe inside out in a way you absolutely have to hear, so definitely stick around for that. Let's kick things off with the granddaddy of what? Ideas. The hollow Earth. Now, this isn't some fringe notion cooked up in a forgotten corner of the internet yesterday. We're talking about an idea that dates back centuries, championed by some surprisingly reputable minds. Imagine, if you will, the brilliant astronomer Edmund Halley. Yes, the very same Halley of comet fame, suggesting in the 1690s that our planet isn't a solid core, but rather a series of 3 hollow, concentric shells, nestled inside each other like some colossal Russian nesting doll. His reasoning? He needed this elaborate multi-shelled geometry to explain the perplexing, seemingly erratic wobbles of a compass needle, which he couldn't quite reconcile with a solid Earth. Pretty wild, right? But then, science got a little more sophisticated. Enter modern seismology, the study of how waves travel through Earth's interior. When an earthquake strikes, it sends vibrations, seismic waves, rippling through the planet. These waves act like a cosmic ultrasound, revealing Earth's internal structure. What they tell us is a very different story. P waves and S waves bounce, refract, and reflect through distinct layers: a solid crust, a vast semi-solid mantle, a sloshing, liquid outer core, and finally, a dense, solid inner core. There's simply no empty space for hidden worlds. And if that wasn't enough, consider gravity. If Earth were truly hollow, or even mostly empty in the middle, we'd experience a significantly weaker gravitational pull at the surface. You'd weigh noticeably less, your car would feel lighter, and frankly, everything would just float off with a gentle breeze. But we don't, do we? Our weight is consistent, gravity is robust, and the numbers just don't lie. Still, despite every earthquake monitor on the planet shouting solid, the allure of a hollow Earth refuses to die. Why? Perhaps it taps into that deep childish part of us that secretly yearns for a hidden clubhouse, a secret garden, or a lush sunlit cavern beneath the crust. Think of Jules Verne's, with its subterranean seas and prehistoric creatures. It's a beautifully captivating image, an ultimate basement where anything is possible. So, while it's undeniably fun to picture and a fantastic premise for an adventure novel, the scientific consensus is clear. Our planet is decidedly not hollow. Ready for a theory that will make your brain do a triple flip? The concave Earth hypothesis takes the inside-out concept to a whole new level. Forget living a sphere. This idea suggests we're actually living one. Imagine being a hamster, but instead of running around the outside of a glass ball, you're stuck to the inner surface, looking up at what you perceive as the sky, but is actually the center of your contained universe. It's an inversion of everything you thought you knew about space and direction. Proponents of this theory would argue that if you shine a laser, it doesn't travel in a straight line out into the cosmos. Instead, it curves towards the perceived center of this inverted world. The math, believe it or not, can be tortured and twisted to fit such a bizarre geometry, where up is towards the middle and down is away from it. But let's bring in a trusty tool of scientific thought, Occam's razor. This principle suggests that the simplest explanation is usually the best. And for concave Earth, Occam's razor doesn't just file for divorce, it takes the kids, the house, and the dog. Think about it. If the stars were truly tiny flecks hovering in the center of our contained universe, rather than distant suns, we'd observe massive parallax shifts every time we blinked or even just moved a short distance. Their apparent positions would change dramatically. We don't see that. Not even a little bit. And what about our indispensable GPS satellites, the ones that guide us through our daily lives? They operate based on a very precise understanding of a convex, outer surface Earth. If we were truly inside a concave sphere, those satellites wouldn't just be slightly off. They'd fling off into a non-existent outer space, or simply wouldn't work at all. Yet, here we are, navigating perfectly fine. So, while it's a brilliant mental yoga pose, a truly fascinating philosophical party trick that forces you to question fundamental assumptions about space and perspective, Concave Earth remains just that, a thought experiment. It's a testament to the human mind's capacity for radical reimagination, but not a physical reality supported by any observable evidence. It's a fun brain teaser, but probably not the true nature of our planetary home. Ever had that eerie feeling that something's just a little too perfect, a little too well designed? Welcome to simulation theory, the idea that Earth, atoms and all, is merely ultra-high-resolution CGI. It's like we're all characters in the most elaborate, immersive video game ever conceived. This isn't just a plot device from the Matrix. It's a serious philosophical proposition. Oxford philosopher Nick Bostrom framed it neatly with his trilemma: either virtually all advanced civilizations go extinct before they develop simulation technology, or they develop it but choose not to run ancestor simulations, simulations of their past, or we are almost certainly living in a simulation. Given the sheer number of simulated minds that could exist compared to original, base reality minds, statistically you're probably pixels. Kinda makes you wonder if you can find the save button, doesn't it? The beauty of this idea is how elegantly it answers some of the deepest cosmic questions, like the fine-tuning problem. Why are the fundamental constants of the universe, the strength of gravity, the mass of an electron, the speed of light, so perfectly calibrated for life to exist? If they were even slightly different, the universe as we know it wouldn't exist, and neither would we. A simulation offers a quick and easy explanation. They were just programmed that way. It's like hitting an update patch that ensures all the parameters are just right for the game to run smoothly. The catch, of course, is testability. How do you prove you're living in a simulation? Physicists are actually hunting for subtle glitches or pixelation in cosmic rays, or looking for limits to computational precision at the quantum level, but so far they keep coming up empty. No one's found the cosmic equivalent of a blue screen of death. Yet the hypothesis refuses to fade. It's a powerful idea because it forces us to confront the nature of reality itself, making our existence feel both incredibly significant and utterly artificial. So, while science can't definitively confirm we're in the Matrix, the thought that our entire world could be a cosmic video game is, well, mind-blowing. Step sideways, just a little, and you might bump into another Earth where pineapple on pizza is considered a delicacy, or where dinosaurs never went extinct. Welcome to the multiverse, an idea that isn't just science fiction, but emerges from some pretty serious cosmological theories. This isn't about parallel dimensions in a mystical sense. It's a concept that pops directly out of inflationary cosmology. Imagine the early universe undergoing a rapid, exponential expansion. Inflation. In this model, space isn't just expanding, it's inflating in countless disconnected pockets. Each of these pockets could freeze into a separate universe, each with its own unique set of fundamental physical laws and constants. It's like an infinite cosmic dice roll, with every possible outcome playing out somewhere. Our Earth-friendly constants, the precise strength of gravity, the perfect carbon resonance that allows complex chemistry, the unique density of water, aren't miraculous or impossibly lucky. They're simply the winning ticket in one cosmic jurisdiction. In a multiverse, our universe isn't a unique miracle, but rather just one of an unfathomable number of possibilities. We're here because this particular universe happens to have the right settings for life. It's a bit like winning the lottery, not because you're special, but because someone bought every single possible ticket. Evidence for the multiverse is, to be honest, indirect at best. We can't exactly peek into another universe. However, some cosmologists look for subtle patterns in the cosmic microwave background, the faint echo of the Big Bang, that could, just could, hint at bruising collisions with neighboring bubble universes. For now, the multiverse remains a mathematical convenience, a powerful theoretical framework that elegantly explains away some of the universe's most perplexing coincidences. But it does make Earth feel less like an improbable fluke and more like a frequent flyer in an unimaginably vast probability space, nestled in its own little corner of the cosmic parking lot. It's a humbling and exhilarating thought simultaneously. If life started here on Earth, the question inevitably arises: where did here get its initial starter culture? Panspermia offers a truly captivating answer. Maybe it didn't start here at all. This hypothesis suggests that the fundamental building blocks of life, microbes, spores, or at least their complex chemical blueprints, didn't spontaneously arise from Earth's primordial soup. Instead, they arrived, hitchhiking across the vastness of space, piggyback on comets, meteorites, or even cosmic dust. It's a cosmic delivery service for life itself. This isn't just a wild guess. There's some intriguing, albeit controversial evidence that keeps this idea alive. Remember the 1996 Allen Hills meteorite? This Martian rock, discovered in Antarctica, showed microscopic blobs that looked suspiciously like fossilized bacteria. While later debates chalked them up to quirky mineral growth rather than definitive proof of Martian life, the door to extraterrestrial origins was undeniably flung open. More recently, Japanese missions have returned samples from asteroid Ryugu, and what they found was astonishing. Not just simple organic molecules, but a rich array of amino acids and other complex organic compounds, far more exotic and diverse than you'd expect to find in a cosmic vending machine. These are the very building blocks of proteins, the machinery of life. Add to this the incredible resilience of extremophils on Earth. Microbes that thrive in conditions previously thought impossible, surviving crushing pressures, boiling temperatures, even the vacuum and radiation of space. These tiny super survivors make the idea of space travel for microbes look less like far-fetched science fiction and more like an intergalactic Uber pool. Now, it's crucial to understand that panspermia doesn't actually solve the ultimate origin of life. It simply relocates it. It pushes the "how did life begin?" question out into the cosmos. But it paints Earth as one big adopted family, a vibrant biological melting pot seeded by wanderers from beyond the stars. It makes you wonder, are we all in some fundamental way aliens? Forget the static globes you saw in school. Earth's crust is a dynamic, ever-shifting jigsaw puzzle on a colossal treadmill. We're talking about plate tectonics, one of the most revolutionary and unifying theories in geology. For centuries, people looked at maps and noticed how South America seemed to fit snugly into Africa. But it wasn't until the early 20th century that Alfred Wegener proposed continental drift. His idea was initially ridiculed, but the evidence kept mounting. This theory explains everything: why fossils of the same tiny reptile pop up on continents separated by vast oceans, why mountain ranges like the Himalayas are still growing, and why the Atlantic Ocean widens by an inch or so every year. It's also why your tranquil California commute occasionally includes a thrilling, albeit terrifying, earthquake. The scientific evidence is overwhelming and beautiful in its simplicity. We have seafloor spreading, where new crust is generated at mid-ocean ridges, pushing older crust outwards. We see subduction zones, where one plate dives beneath another, recycling material back into the mantle and triggering volcanoes and deep ocean trenches. Paleomagnetism, the study of Earth's ancient magnetic field recorded in rocks, shows symmetrical magnetic stripes on either side of mid-ocean ridges, clear evidence of new crust forming and preserving the magnetic orientation at the time. Today, GPS stations, precise to the millimeter, track plate motion in real time. Tokyo, for instance, inches a few centimeters closer to North America every 12 months. It's not just a theory, it's an observable, ongoing process. What's the engine driving this planetary dance? It's a complex interplay of forces. Primarily, it's mantle convection, where heat from Earth's core drives slow, massive currents of molten rock in the mantle. Then there's slab pull, where the dense, sinking oceanic crust at subduction zones literally pulls the rest of the plate along. And finally, ridge push, where the elevated mid-ocean ridges push plates from behind. Without this constant geological recycling, Earth would be a very different, very dead planet. Carbon, vital for life, would get locked up in rocks, plants would starve, and so would we. So the next time the ground rumbles beneath your feet, don't just feel fear. Take a moment to thank a tectonic plate for keeping our planet's climate thermostat working and for making Earth such a perpetually fascinating place. It's the slowest, most impactful roller coaster ride you'll ever be on. Here's the shocker you stayed for, the theory that underpins much of Earth's habitability and makes life as we know it possible. Earth is a giant, self-starting electric motor, a colossal geodynamo. Deep beneath our feet, churning within the planet's fiery heart, lies the outer core, a vast ocean of molten iron, nickel, and other metallic elements. But it's not just sitting there. Thanks to Earth's rotation, which imparts a powerful Coriolis effect and the intense heat escaping from the solid inner core, this molten metal is constantly swirling, convecting, and spiraling. This motion generates powerful electric currents, and as any physicist will tell you, moving electric currents create magnetic fields. The result? A vast, powerful magnetic field that stretches tens of thousands of kilometers into space, forming an invisible shield known as the magnetosphere. This isn't just a pretty phenomenon, it's our planetary life support system. This magnetic field deflects the constant, deadly stream of charged particles known as the solar wind, which would otherwise strip away our atmosphere, boil our oceans, and blast all life on Earth with lethal radiation. Without this geodynamo, Earth would become a larger, deader Mars, a barren wasteland unable to sustain complex life. The flip side to this incredible planetary engine is its dynamic nature. The magnetic poles aren't fixed. They wander, sometimes quite rapidly. And occasionally, over geological timescales, they even reverse entirely, with north becoming south and south becoming north. We know this from paleomagnetism, where ancient lava flows preserved the direction of Earth's magnetic field at the time they solidified. Ship logs from centuries past, aircraft runways, and even the compass app on your smartphone all need recalibrating yearly to account for the magnetic pole's drift. These reversals, while not instantaneous, are dramatic events causing temporary weakening of the field. Lose the geodynamo, and Earth becomes a barren rock. So, the next time you complain about a bad cell signal, remember the planet itself is broadcasting life support 24/7, thanks to this incredible self-sustaining electric motor deep within its core. It's truly the most mind-blowing theory of all, because without it, none of the others would even matter. Before plate tectonics won the scientific consensus, another compelling idea tried to explain the jigsaw fit of the continents, the expanding Earth theory. Some geologists proposed that all the continents once covered the entire surface of a much smaller globe. Then, as Earth expanded, much like a balloon inflating, the crust cracked and fragmented, creating the continents and the vast ocean basins we see today as they drifted apart. It offered a neat, visual explanation for continental separation and the formation of rift valleys. However, once satellite laser ranging technology came online, allowing for incredibly precise measurements of Earth's radius, this theory was definitively put to rest. We now know that any radius growth is negligible, far less than a millimeter per year, essentially measurement noise. So, while it was a cool visual and a clever hypothesis, there are no planetary balloon animals here. Alright, that was a whirlwind tour. Which of these 7 theories twisted your brain the hardest? Was it the idea of an inside-out Earth, the unsettling thought that we might be living in a cosmic video game? Or the notion that life itself was space-seeded from beyond our world? Drop your number in the comments below and let's get a conversation going. And if you've got a friend who still thinks our planet is just a boring old rock, do them a favor and share this video. It's evidence that they're clearly not looking at the right conspiracy subreddit, or, the right science channel. Wow. We've tunneled through hollow myths, flipped the universe inside out with concave geometries, booted Earth in simulation mode, parked it in a multiverse lot, considered it seeded with alien microbes, ridden the slowest roller coaster on tectonic plates, and marveled at the planet-sized electric motor that powers our very existence. 7 layers, 7 radical rethinks, and 1 undeniable takeaway. The deeper we probe, the weirder, more complex, and infinitely more fascinating our home gets. Science is the ultimate filter sifting fact from fantasy, but it's imagination that keeps the questions coming, that pushes us to look beyond the obvious. So keep asking, keep testing, and whatever you do, keep looking down, and up, and all around. Because the ground beneath you, the sky above you, and the very fabric of your reality are never just what they seem. If you enjoyed this brain stretch and you're ready for more content that makes reality feel like a suggestion, not an absolute rule, then hit that subscribe button and join our journey of cosmic curiosity.